Hi everyone, I am Ganga Devi from the Standard Fair Oaks Rajaratnam College for Women, Sivahasi. So, through this tutorial we are going to see the data structure Q. Already we have seen what is a stack. It simply resembles the stack in many ways. Likewise, here Q is also a linear data structure which is used to store and manage the data in a linear order. And the main difference between stack and queue is here we have two pointers. One is pointing to the front end and another one is pointing to the rear end. Okay. So, in not like stack where all the insertions and deletions are happening at the single end, here both are happening at two different ends. Okay. So, here the order followed is first in first out or last in last out. The operations that are followed in queue are as follows. So, these are the principal operations that are followed in queue. So, first one is the insertion operation where the element insertion is happening at the rear end of the queue. Next one is the deletion operation where the deletion is happening only at the front end of the queue. That is, if you are going to a ticket counter or somewhere, then if you are in a queue means then after you fulfilled your work, you just get out of the queue, right. So, that is why we are calling it as first in first out. Okay. So, the remaining operations are same as that of stack, peak which returns the frontmost element of the queue and is empty and is full. We can check that condition of the queue. The operation we are going to see, the first operation we are going to see is the NQ operation. Here before inserting any element into the queue, we have to check whether the queue is full or not. Okay. So, if the queue is full means it is already overflowed, we cannot insert any element into that queue, right. If it is not empty means then we have to insert the new element into the available position. For that purpose we have to move forward the rear position to the front, that is rear is equal to rear plus 1, and after that we will insert the new element into the queue as shown in the diagram, right. So, this is the NQ operation. Likewise, for dequeuing the queue, that is for deletion operation in the queue, what we have to do is first of all we have to check whether the queue is empty or not. If it is empty means we cannot retrieve any data from queue, already it is empty, right. So, we have to check it first. If it is not empty, then we have to move the front position one position further, and after that we have to return the first, that is on the front element, we have to return that front element. Okay. So, the next operation is the peak operation, that is here we are not going to delete any element from the queue, just we have to retrieve the front element, that element that is pointed by the front. Yes, the front element is 1. After that what we are going to see is the applications of queue. There are many applications that are followed for queue. Major one is the job scheduling or print scheduling in the systems. Okay. So, in OS we all know that many jobs are enqueued at any time in the operating system, and the first come first served basis, the first job that is entered into the processor is getting executed in the system, isn't it. So, here also the same thing has happened, but the problem with queue is look at the last line, here only one job is currently available in the queue, right, but there are three spaces are there, but the front elements already deleted from the queue, the front two positions, it cannot be reused here. That is the major issue with the queue. Even though the queue is empty, we cannot reuse the front positions in the queue, right. That is why we are going for circular queue. Okay. It is same as the queue, it is also following the FIFO format and it is also linear, everything is same, but the major difference is here we are going to represent the queue in a circular position where the end and beginning are getting connected. Okay. So, the operations that can be performed in circular queue are also the same operations as queue, but the major thing what we have to do is in case of deletion or insertion anything, what we have to do is instead of moving the front to one position or rear to one position, what we have to do is front is equal, that is we have to move the positions like front or rear anything plus 1, we have to modulo that particular value with the size of the queue. Okay. So, in that manner what may happen is from 0 to the size of the queue, it fulfilled all the data, whether we are going to insert or delete or something. After reaching the size, it simply again moved to 0. That is, we are not going to waste the memory hereafter, we won't waste the memory. That is, the available spaces will be reused automatically in a circular fashion. So, let me see them. So, in case of enqueuing 10, look here, it is a circular queue with the size 6. Maximum size is 6. Okay, 10 is getting inserted where front and rear points to the 10. Now 20 is getting inserted, rear is moving to point to 20. Again 30 is getting inserted. Here 30 is pointed by the rear pointer. Now I am going to dequeue the circular queue where the 10 is getting deleted, front is moving to point to 20. Again I will insert 4 more elements here. You can see that. So I can insert again from 40, 50, 60 and 70. That is, queue is always getting encaged. The memory wastage is totally getting eliminated. That is the main advantage of circular queue. Okay. So again after dequeuing, it's simply it's doing its work as it is. Okay. So this is circular queue and queue. So thank you for watching.